All right, we're into module 2. And in module 2, we're going to observe star clusters and study the evolution of stars. Okay, in this video, I'm going to show you how to put in your observations. So let's slide on down to the observing section. Okay, now each team is going to observe 3 star clusters, a young one of intermediate age, and an old one. And I'll show you how to pick those in just a moment. The first thing is to figure out what ranges of right ascension are currently acceptable. Over the course of the year, the sun moves through the sky, and wherever the sun is, we can't observe there right now. So make use of this table. For example, when I'm shooting this video, it's currently the beginning of February. So I'm kind of between this row and this row. This is January 21st. This is February 21st. So kind of between those, my minimum right ascension would be 4. My maximum right ascension would be 14. Anything in that range is going to work. Now, outside of that range, no, you're in the bright sky. In fact, when you pick your targets, you may want to favor the middle of this range. The middle of the range will be good for longer during the night. If you pick just the beginning of the range or the end of the range, your target's observable only for a short period, either at the beginning or the end of the night. And that makes it less likely that your observations will come back. The telescopes might be doing something different. But if you pick the middle of the range, you basically have the whole night to work with. At some point, the telescope should become free and your observations will get executed. Okay, so target selection. For target selection, you follow this link. This will take you to a different version of the MW module. This is an alternative version where with a different emphasis. Here, it's more detailed. The students are actually going for a scientifically publishable result, which is kind of cool. In the version we're doing, it's a more lightweight version to learn the scientific concepts, and then we'll move on to deeper astrophotography. But the table of targets is in this version here. So you come here and you're looking for tables 1.2 and 1.3. They're a ways down. Here's table 1.2. In 1.2, you have what we call open clusters. These are in the plane of the galaxy. They tend to be closer to us, and they're younger. In table 1.3, you have globular clusters. They're floating up above the galaxy. They tend to be farther away, and they're older. Okay, so in table 1.2, you have your young star clusters and your intermediate age star clusters. So go into the table, knowing your right ascension range, pick one young and one intermediate. For example, this one's around 0 hours right ascension. It's not in my range. I have to scroll down until you hit the beginning of your range. And I should point out this table goes on and on. It's just listing the first 25. You can use the next button to see targets at greater right ascensions and greater right ascensions. Okay. So pick a young, pick an intermediate, and from table 1.3, these are the globs. They're all old. Pick one of these, also within your right ascension range, your acceptable right ascension range for that time of year. Now, as you're doing this, you need to partner with another team, a team that sits next to you in class, and make sure that you're picking different targets. Because later on, we're going to do an inter-team activity where you have analyzed your targets, they have analyzed theirs, and you're going to swap them, and we're going to do some activities. It's important that you have different targets. So pick your targets, they're going to pick their targets, and then find a partner team and talk to each other and make sure you don't have the same targets. If you do have if you have the same target, one of you will have to swap to a different target. Okay. Once you have your targets, go to Skynet. So here we are at Skynet, and we're going to put them in. 3 targets per team. So one team member can submit one team member can submit another, and one team member can submit the third, the young, the intermediate aged, and the old. Okay. So I'm going to submit I'm going to submit an old one. So I'm going to add a new observation. And the target that I've picked, it's already loaded up here, but I'll go through the step. NGC 3201, search, and it will find it on the Sky Viewer. We'll load in the DSS. It will fill in the coordinates. It will fill in the name. Okay. Now, the settings. The settings will be a little bit different than what we did in Module 1, Module 1A and 1D, the optical modules, the moon and the planets. Max sun elevation, we're going to go with -18. Back in Module 1, we just did -12. That's when the sky is mostly dark, but not all the way dark. But here, these star clusters are much fainter than the moon, much fainter than the planets. So we're going to wait for all the way dark. So you want -18. Min target elevation, we're going to take 20. And we're not going to be super picky. It doesn't have to be super high in the sky. Let's go for 20. Basically, this observation is going to be a little bit different from the other observations we place in MWU. This will be a multi-telescope observation where we'll say any of these telescopes are acceptable, and we'll take whichever one's available first. So it's just easiest if we set the min target elevation a little bit lower, accommodating more possible telescopes. Min visible hours should be visible for at least an hour, or it's probably not worth trying. And then the moon settings. And these will be a little bit different than we did in Module 1A and 1D. Well, 1A, we're looking at the moon, right? So in 1D, we're still pretty generous here. We would observe even during a full moon because the planets are so bright, it doesn't matter. These targets are faint. So set max moon phase to 30 and min moon separation to 60. So what this means is if the moon is down, it's going to observe. Okay. If it's up, it will only observe if these conditions are met. If the phase of the moon is less than 30%, in other words, it's a crescent, it's not producing a lot of light. And min moon separation of 60 degrees. It's 60 degrees away. The moon is, when you're observing fainter things, like astronomers typically do, the moon is your enemy. And it brightens the sky when it's up. When it's down, it's not a problem. But when it's up, it brightens the sky, making it hard to observe the fainter things in your image. And it really messes up the blue in particular. So things to keep in mind. These should keep you safe. Now, if you're trying to get your observations back quickly, you may want to look at the sky viewer, see where the moon is relative to your target. Okay, let's do that. So my target is right here. If you don't see it, hit now, move forward in time. Sun just set. There's my target. My target's rising when the sun is setting. So that's kind of nice. I picked a target in the middle of my right ascension range. It's visible all night. Where is the moon? It's way over here, that little gray dot. So for me, in fact, if I do one more click, you can see close to the sun. It's almost a new moon. So the moon's not a problem for me right now. If you do this module close to a new moon, you really don't have to worry about it. But maybe you're observing some other time. Let me back it up a little bit. See the moon there? So my target's actually not super close to the moon. It's mostly 60 degrees away. Each one of these ticks is 10 degrees. But I'll put it back to today. Okay. But if you find that the moon is close to your target, you may want to pick a different target unless you're willing to wait. Now, if the moon is to the left of your target, that's okay. The moon moves to the left here, moves closer to the sun in this direction. So if it's ahead of your target to the left, yeah, maybe it's too close right now, but in a day it will be here, and the next day it will be here. It's moving farther away. If it's to the right of your target, and just a little bit to the right, your observations won't go through for a while because the moon has to move across your target and then 60 degrees away before it will begin to observe. In that case, if you're trying to get information back quickly, you may want to pick a different target. Maybe one at a much greater right ascension, and you try to get the data before the moon gets over there, or if possible, at a lower right ascension, and the moon's already past you. Okay. All right. So, think about that if you're trying to get your observations back quickly. This semester, you're probably going to become hyper aware of the moon's phase cycle, where the moon is in the sky, things you normally ignore, take for granted. You're going to become aware of it. You're going to have to plan your observations around it. All right. Once you're good here, we're going to next pick our filters. Not our telescope, but we're going to pick our filters next. Okay. And for this, we want BV, and I. Make sure you don't have any other filters selected from before. BV, and I. Blue, V is the middle of the visual band. It's green. R is red, and I is almost infrared. It's not technically infrared, but it's on the infrared side of the visible band. Okay, BV, and I. Save and continue. And you'll be presented with a list of telescopes that can reach your target, and they have all the bands you're looking for, BV, and I. And so I just have three options here. And what you want to do is to select all prompt telescopes that you have access to on this list. And in the module write-up, we may mention some other telescopes that are also acceptable to use. For example, the OAUJ-CDK 500 telescope. It's in Poland. It's a good telescope. It has BV, and I filters. And so if you're doing a northern target, I chose a southern target. If you're doing a northern target, you may see that telescope. You can accept that one as well. But definitely click all the prompt telescopes. If a bunch of these are closed, you may want to open them because we have prompt telescopes at all sorts of different sites, not just Tololo. Okay. Then we're going to save and continue. Now on this page, the first thing you want to pick is generic. You don't want to pick a particular telescope. This observation we're designing to work for a generic telescope, and then Skynet will convert your exposure times to give you a similar observation on whatever telescope it dispatches on. And we selected 3 acceptable: prompt 5, prompt Meckering, prompt 8 for my Southern Hemisphere target. Those are the options I was given. So BV, and I, 1 exposure each. We're going to get more than 1 each, but we're going to do it in a particular way. And then the next thing is filling in the durations. And you get that from this table. So let me find my target here. 3201. Here it is. And the first 4, where's that scroll bar? Slide over here and come back to 3201. Oh, I can scroll this way with my mouse pad. Here we go. 3201. This is B, V, R, and I. There's some other filters too. We're not going to use those. B, V, R, and I. If I scroll up here, you'll see B, V, R, and I. Okay. And here it's giving you the recommended exposure times for the generic telescope. 90, 75, 60, 30. Each one's different. I'm going back to Skynet, 90, 75, 60, 30. I already have them in here because I've already practiced once before shooting the video. So grab the exposure times from the table, put them in here. Okay. Now you can see if I hover up over different telescopes, it's changing those exposure durations just a little bit. Because Skynet knows how good each telescope is. For example, the Prompt 8 telescope is bigger, collects more light. So I can get the same signal to noise, the same image depth in shorter exposure times than I can on these other telescopes. And so we're saying any of these are acceptable, and the first one that's available, Skynet will use. The idea is to get these observations back fairly quickly. Okay. Don't need this delay, delay. So what we do need is repeat. We're going to enable this, repeat this observation 5 times with 30 minutes between each. So why do that? Why not just observe 5, 5, 5, and 5 and get it all out of the way? Well, that is putting all your eggs in one basket. For example, what if someone observed the moon or a bright planet or a bright star right before your observation was dispatched? You will have a ghost, a residual image. Remember, a bright object will leave a ghost in everybody else's image for the next 20 to 30 minutes. So by spreading these out, I run through the filters once, and then I'm going to wait 30 minutes. Maybe one set gets a ghost in it, but the others are then okay. When we combine them, we can remove defects like that, residual images, ghosts, as long as it's not in every image. If it's just in one set, we can get rid of it. Maybe it got cloudy. If it gets all the way cloudy, we have cloud sensors at our observatories that stops the observing. But if it's just thin clouds, maybe thin clouds passed in front. And so one of your image sets aren't as good, maybe not very good, but your other ones will still be good. And we can proceed. Okay. So, oh, and the other reason to do this is it gives everyone else a shot. While you're waiting 30 minutes, it will start carrying out observations for the other teams and other targets. That way, everyone gets something. If we do 5, 5, 5, and 5, you'll either get everything or maybe nothing, because maybe someone else got everything and you got unlucky and you got nothing. By doing it this way, everyone at least gets something. Okay. So repeat this observation 5 times with at least 30 minutes between each. I think the default is days. Don't pick 30 days, or you'll get one set and it will wait a month before it takes the other. 5 times with 30 minutes between each. Okay. Save it. And I picked a time account without enough credits. In fact, all my time accounts don't have enough credits. I'll have to adjust that. But save it. It takes you to the next page, and then you submit it. And then it takes you back to the main observation page. I submitted this observation already, and here it is. And so once your data starts coming back, you want to check this. And these look good. A little bit of a pointing error. It's not centered as well as I would like, but acceptable. And just check your observations. If anything is problematic, you can just resubmit here. Maybe only 2 sets are problematic. So when you resubmit, just repeat twice. You don't need to repeat the whole thing. Just anything that went wrong, go and get that, but you don't need to double your data, double your expense. Okay. Oh, and also be sure to record this in your observation log, so your teammates will be able to get to the data as well. Okay, that's it for this video.